Okay, during the last video, we looked at scientific notation with very large numbers. Now we're going to go the opposite and look at scientific notation where we have very small numbers. Now, firstly, what do I mean by a very small number? What I mean is a number that is between, so we're going to write an x here. X is between 0 and 1. Okay, so we have examples of numbers such as 0.35. This is a small number. Okay, normally in science we work with much smaller numbers than this. You might have a number like 0.000062. Okay, where do we use these kinds of numbers? Mostly with things like distances in cells, okay, wavelengths of light and those kinds of things. All right, these are all very scientific things where we need to use really small numbers, and it's much more effective if we can write them using scientific notation. Now let's have a look at this 0.35. Okay, I want to start by looking at what happens, how do we get from, I'm going to just move it slightly, how do we get from 35 to, or 3.5 to 0.35? How do we get from there to there? All right, now you guys hopefully know that if you go from 3.5 to 0.35, we divide by 10. Okay, that's pretty clear, right? Now, we can therefore write 0.35 as 3.5 over 10. All right, but that's not the way we do scientific notation, okay? As you saw with the other example, we always write it as times 10 to the power of something, okay? So we need to somehow work this in, all right? Now, firstly, we've got to divide here, but we want to times. So what we're going to do is, instead of writing it as 3.5 divided by 10, we're going to write it as 3.5 times 1 over 10, 1/10. Okay, that's now multiplying. Okay, so we're getting a little bit closer to what we wanted. And you can see here that it's effectively the same thing. All right, now we need to now think back to what we've been doing lately with negative exponents. Okay, so we have in the last lessons looked at things in the denominator of a fraction and how to move them to the top. So how do we bring this 10 up to the top? Well, what we have to do is change its power to the opposite of what it currently is. Now you can see this 10 currently has a secret little 1 here that we don't write. So if we bring the 10 to the top of the fraction up to the numerator, then it becomes 3.5 times 10 to the power of, we change that sign to negative, minus 1. All right, and this is how we work with scientific notations with very small numbers. Okay, now normally you're not going to have to go through this entire process. Let's look at our example that we have here on the left. So if we have 0.00000062, the same as with the example that we used in with large numbers, sorry, we always start with our first non-zero digit, okay? So we know in this case we're going to have 6.2, okay, because 6 is our first non-zero digit, and therefore our decimal point is going to move to here. All right, so 6 is the first non-zero digit, the point goes directly after that. It's going to be times 10 to the power of, and again, same as with large numbers, we're just going to count how many places we moved it. So 1, 2, 3, 4, 5, 6 places. So it's 10 to the power of 6, but because we're looking at smaller numbers, it's minus 6. Okay, now if you think about it, this is the same as 6.2 times 1 over 10 to the power of 6, okay, which is the same as 6.2 divided by 10 to the power of 6. But as I said, that last bit's not something that we want you to worry too much about doing right now, but it's good to understand it. Okay, so let's do a couple more examples. If I gave you 0.00536, okay, so again, currently our decimal point is here after the first 0. We want it to move over here between the 5 and the 3. Okay, so we're going to have 5.36 times 10 to the power of something. How many places did we move the decimal? 1, 2, 3. Okay, so it's 10 to the minus 3. All right, so this is how we write very small numbers with scientific notation. Now we also need to look at this the other way around. So if we have something in scientific notation, for example, 7.68 times 10 to the power of minus 5, how are we going to write this in standard notation? Now with small numbers you have to be a little bit more careful, because as you can see up here, the 6.2 here moved from the very end. Okay, so you need to make sure you leave yourself enough space in order to keep things big enough that you can fit all the zeros in. So what we do is we start with the 7.68 here. I'm just going to move that down slightly so I have some more space. So 7.68 we start with here. Now, this is where our decimal point currently is, all right? But we've moved it by 5 spaces. So what you need to do is move it back 5. So we're going 1, 2, 3, 4, 5, and that's where our decimal point is now going to be. Now, the difference with small numbers is when you fill in the gaps, you fill them in, but you need to also remember to put a leading 0 in before the decimal, okay? If you don't do that, you don't have a correct answer, okay, because it doesn't really make sense without the 0 in front. So in this case, our answer is 0.0000768, and you need to write that out fully after you've done this, okay? Let's try another one just to make sure that you've got it. If we go, and let's try one with some zeros just to make it a bit more interesting. So 2.0053 by 10 to the power of minus 2. Okay, now this one's a little bit strange because normally, you're not going to end up with decimals left after, but in this case you will. You'll see that in a second. So in this case we have 2.0053 and we have 10 to the minus 2, therefore we need to move the decimal point 2 spaces. Okay, once you've moved it those 2 spaces, you'll see that now we have 0.0. Okay, so this gives us as our final answer 0.02053. So we need to make sure we keep those extra zeros there, okay? We don't actually do anything with the zeros that are in between. They're very important. They need to stay there. Later on, when you do more work with science, you'll start looking at significant figures. And in that case, we change it a little bit. But for now, as long as you can change numbers between large and small and scientific notation and standard notation, then you're going to be fine. Okay, good luck.